The word gearless is termed for the cars where user don't need to manage the gears. And in the same ways, the term serverless. In the gearless cars, gears are there, but the user is not managing them. Same goes with serverless. So in your AWS Lambda code, when it is deployed on the cloud, you don't need to manage the servers underneath, and hence we call it a serverless offering. Every Lambda is invoked by a trigger, and we call this an event source. Those event source could be S3, API gateways, SQS, and DynamoDBs. If we configure a Cloudwatch in such a way that it triggers the Lambda in a defined frequency, this behaves like a cron job. There are certain rules around an AWS Lambda. So you are given a maximum execution time of 15 minutes. That means if your Lambda is not able to perform the job it should do in 15 minutes, the infrastructure will mark this Lambda as a timeout. So it will time it out deliberately. Then you can have 1000 executions per AWS region concurrently. Anything which goes over this marks a 429 error. Also, AWS Lambdas can be deployed in multiple versions. So we are just starting with the AWS Lambda using .NET Core. And those are the libraries which we are going to use. Amazon Lambda Core, Amazon Lambda Serialization JSON, AWS SDK, SQS. Also, we'll need IAM to create a few roles, and we are going to assign those roles to the Lambda. SQS is our event source, and Cloudwatch is where the Lambda is going to log whatever we are going to print in the Lambda. So as such, there are no prerequisites. I tried my level best to create a course which is operating system agnostic. I'm going to use Visual Studio Code as my choice of IDE, .NET Core 3.1 as the choice of framework. A few extensions which we may need since we are using Visual Studio Code. So the extensions should be also working over any operating system of your choice. Also, we are going to use some .NET Core CLI extensions. I'll cover this next. And just now we are going to start with our first Lambda using .NET Core. I have kept it simplest possible way. So I'd already installed this .NET CLI extension. You can go and see what all things it offers. It is there on GitLab. So for now, if you have the .NET CLI install, you need to run this command and you shall be able to get some .NET Lambda commands on your machine. We are going to use those .NET Lambda commands at some certain point of time later. For now, we are starting with the simplest possible thing, which is the class library. We'll create a class library from scratch in .NET Core, and then we'll add whatever we need on top of this, and then we'll deploy the Lambda, and then we'll invoke it in a synchronous way. Right, so let's quickly, here I am going to do in mkdir say prac, and I'll jump to prac. Fine. Here I'll issue some commands, and those commands will let me create a new class library project. So it is .NET new class lib, and I'll name this -n is for name, and I'll name this a new Lambda, or maybe new lambda for the sake of simplicity, and I'm going to use the framework netcore app 3.1, and I'll hit enter here, and it will give us this new lambda as a directory. So if I ls here, you'll find this. So I'll quickly jump to this new lambda and I'll open this in Visual Studio Code. Okay, fine. So this is mere a class library, and we are now we'll start adding a few things on top of this, and we'll start creating our first function. So I have an extension for nuget installation, which is by gmrog. This is a cool nuget package manager for Visual Studio Code, and since it is for Visual Studio Code, it is operating system agnostic, so you may use it anywhere you want. So okay, we'll install a few packages here first. So let me get rid of this, and Control Shift P turns on our command palette. If you are on a Mac machine, it is Command Shift P. Okay, in this command palette now, I'll select Nuget Package Manager, add package. It is now asking for the package which I am looking for. I am looking for amazon.lambda.core, and on the basis of my input, it made a search online in the Nuget repository and found that those three could be the choice which I might be looking for. I'm looking for amazon.lambda.core. I click on that and I'll use the latest one, which is 2.0.0. What it did is it added just this simple line package reference here. I'm going to add another one, the same thing, Nuget Package Manager, add package, and the package name I am looking for is amazon.lambda.serialization.json. Okay, so this is what I was looking for. So I have selected this, and again I'll select the latest one, which is 2.0.0. So far so good. We have added the packages which we may need, and the next thing which we are going to do here is we'll jump onto the class. I'll rename this class to a friendly name, maybe lambda class. Okay, and I'll do the same here, lambda class. Fine. Then let's do a .NET build so that our IntelliSense works in a better way. So we did a .NET build right away because we have installed a few Nuget packages lately. Now we'll start with decorating this namespace. So first thing we need is some decoration on the namespace, which is we are going to use an assembly as a lambda serializer, and our lambda serializer would be type of amazon.lambda.serialization json.json serializer. Right, this would be our serializer, and we are going to leverage this serializer to pass requests and to get responses on the wire. in the serialized format. So far here so good. So our first Lambda function, everybody goes here with the name of function, and we will pass some model. So let's say response model. We'll create a type for this at a certain point of time, right in a minute. And this function is, ladies and gentlemen, our Lambda function. So a request model of type request. Also, now we need a Lambda context here. So this is the interface to Lambda context, which gets satisfied when this Lambda gets called. Now quickly, let's create the response model and the request model. So we'll just create classes around that, and that would be like easy. So let's say public, and we'll call this request model, and we'll create a prop for the sake of simplicity. That would be string name. Yes, we are going to create a hello world now. So you guessed it correct, and I made a mistake. It should be public class. Okay, all green now. So the request model is here, and on the same lines, let me create a public class of response model, and we will respond with a public string, and we'll call it response get set. Okay, so this is what we got it, and now we are going to respond from this function, but before that we'll write some code in here, and we will deploy it to AWS Lambda. The request which we will receive shall have a name in it, and we should respond to that in response model. So response model, say RESP, or ESP, I wanted to that, and new response model. So the response which should look like hello, and the name which comes from request. Okay, so far so good, no error handling. We are not checking anything in here. We just want to make it work so that we can see some things working, and we are going to return this RESP. Fine, so we are kind of done with writing our first function here. Okay, now comes the deployment. So deployment can happen in multiple ways. We are targeting two ways. One is by the .NET CLI, and then the other one would be, we'll be using the AWS console, that is the site provided to us by AWS, and we'll create some artifact here, and we'll drop this artifact to AWS console by creating our function manually. So first things first, I'll rather go and show you the console. Let's start with that. Here I am in my AWS console. For the sake of cleanliness, I have selected a region where I don't work much, which is North Virginia. Though I use much in this region, AP South 1, this is the one which is closest to me geographically. But for now, let's start with US East 1. Okay, so To go to the Lambda dashboard, you may go through it using the recent visited services. If you have recently visited Lambda, you will get the option Lambda here. If not, then if you click on this triangle next to all services, you will see right under compute, this is the option called Lambda. Or if you are too lazy and you don't want to do that also, you may start typing and you'll get Lambda. Anyways, we are going to land to the same dashboard, right? Fine. So this is the dashboard which is being greeted to us. So you'll see that I do not have any functions for now. I'll just go and I'll hit create functions. I'm going to create it from scratch. Okay, the function name. This function name is disconnected from whatever we have written in our class as the name of the class. Whatever we have written the name of the function. So it could be anything. Let's say it is May, June, July. Fine. Okay, and the runtime. So we are programming this in .NET Core 3.1. So I have selected this. Next thing, it talks about permissions, and we'll go here and we'll see that it is asking us for a role. So a role is basically an IAM object which comes with a few policies attached to it so that it may or may not access a few AWS services. So when we create this and when we assign this role to this Lambda, what happens is that we restrict it or we open the gates for it to access a few AWS services. You can see here it says Lambda will create an execution role by this name with permission to upload logs to Amazon Cloudwatch logs. If we do a console.write line in our code, or maybe if we are writing it in Python, if we say print, where does our print go? You can find it here in the Cloudwatch logs. So it will create a log group for you by the name of the function, and there you can find whatever you are logging. For now, I'm keeping it like this only, and by not complicating it more, I clicked on create function. It should greet me with some sort of visual dashboard where we can now do a few more things. Right, we are almost there. In this function dashboard for our function, which is May, June, July, we do not have a trigger yet, we do not have a destination yet, but let's talk about a few more things which we have already, which is first the ERN, which is the resource name, and this is the resource name of our function. Then we have the runtime setup. We have a package size of that, and you can see that we do not have a package yet configured. So this handler thing is what we are going to change, but with the zip of the Lambda which we have created right now. So what I'm going to do is I'm going to jump to the window of Visual Studio Code. I'll issue a few commands, and then we'll have a package of the Lambda. So for that, I have already installed this tool of .NET, which is the CLI extension, and I'm going to use this because this gives me some extensions over the regular .NET CLI. And using a command called .NET-lambda, I'll package this up. So quickly, let's jump on to the window of our Lambda class right here. Fine. So here I will issue the command .net. Okay. This should be visible now. Sorry for the glitch. .net lambda package configuration is release. Our framework is net core app 3.1 and I'll press enter. So what it is going to do is it will build everything and it will create a publishable lambda zip. Okay, so here is our package. I'll just copy this path right now. I'll jump to the console window and I'll say that I am going to upload the lambda from a zip file. It will ask me which zip file now. So I'm going to click the upload button and then I'll give it the name of the file which I just chose. Right, so this is the file which we have just created and I'll just click on the save button and it will save it for me. Okay, now the next thing is we are going to change the handler. This handler should look like in the way that the first thing should say the name of the assembly, which in our case is the DLL, which is new lambda.dll. Okay, so I'll just say new lambda.dll. Next thing, we are in search of the fully qualified name of the class which contains the function. So that would be new lambda dot lambda class. So we'll write new lambda dot lambda class, and finally the name of the function, which is in our case this function. So we'll write this function and we'll save this. So that is it for the first time. Our lambda with .NET Core is ready to get invoked. How do we invoke it? For now we are going to invoke it using AWS CLI, or maybe any CLI of your choice which gives you this facility you might be known of. I'd be using a few CLI commands for this and I'll invoke it right away. Though the command which I just told you, the .NET tool which you may have installed by now, gives you a few functionalities over the regular .NET CLI. I'll start with .NET Lambda, and I'll hit enter and you'll see that it speaks that you can do so many things using it. So I'll say .NET Lambda and I'll ask it to list functions, and it will go and it will hit my account on AWS depending on the CLI configuration which I have done on AWS CLI. So I have already installed AWS CLI and I have configured it to hit my US East 1 region with those credentials. don't worry about access keys and secret keys. I'm going to change them by the time this video is on air, right? Okay, so this is pretty much it, what you can do in terms of deployment and seeing the deployment from the CLI. Right, next what we are going to do here is that we'll invoke the Lambda and we'll see what responses we are getting from it. For this, here we'll issue a command AWS Lambda and we'll invoke this. Our function name is May, June, July. Also, we need to pass a payload. Remember the request message, so we'll pass the payload in the form of JSON and the name would be, let's say, May, and this is it. This is our payload, and I'll just hit enter. Something has gone wrong here, but our command is absolutely fine. In terms of PowerShell, you may need to do a few extra things around this. So the first thing would be like you'll create a payload variable, and this variable shall have the payload converted in the form of base64. We do pass our payload in the form of base64 to the Lambda. So to convert it into base64, what I'll do is I'll use this convert to base64 string, that is I need to write down text encoding. Okay, and now I need to select that UTF-8 and I'll get the byte array from the string which we had written earlier. So that string would come from here, this string. I'll copy this and I'll paste it here, right? Okay, so in PL we'll get the base64 converted string. We'll run the command over once again for good, but in place of the payload we'll just pass on the newly created variable in the previous line, and the output also, which we haven't saved previously, we are going to save it in, let's say, output.json, and I'll hit enter once again. Fine, now we have got this output.json with us, and I'll open this in Notepad, output.json. Fine, so here it is. It says the response is hello May, and this is what we want. So we have invoked our Lambda function in a synchronous way. So a Lambda can be invoked in a synchronous way and a Lambda can be invoked in an asynchronous way. When we say synchronous way, that means when the one who had issued the command to invoke the Lambda wait for the completion of the Lambda, and this is what we call synchronous. Asynchronous way is when we fire and forget it. So let's say you pushed a file to S3, it actually created an event. This event is pushed to an event queue and that triggered a Lambda. That is an asynchronous way of executing an AWS Lambda. We have created a Lambda, we have deployed this, and it is working in an expected manner. Let's see the supporting cost around our Lambda, which is I'll start with rather Cloudwatch. right. So if I hit Cloudwatch and if I jump to log groups, in the log groups you'll see that there's a log group created around the name of your function, which is May, June, July, here, right here, and the execution is here, like it can be seen here. Probably the last one would give you a report of the build duration and the memory you utilized. But what made your Lambda write to Cloudwatch? And the answer is IAM roles. We'll hit IAM and then we'll jump on to the roles. In those roles, I am going to search for May, June, July role, and I'll click here and I'll see that there is a role and a few policies around this. This is the attached policy, and if I open this policy and if I click on policy summary, I'll see that it is limited to write to Cloudwatch logs. If I hit on this JSON button, it will let me see that what all policy statements are executed around that policy. So this is one. It will allow to create a log group on this ARN. Another one is it will allow to create log stream and put log events and on this resource. So yeah, for now this is it. Finally, here is a sneak peek of how to deploy a Lambda using .NET-lambda command line tool. With that, stay safe and I'll see you in the next video. Thank you for watching.